In this video, we're going to see 3 demonstrations, 2 new ones, and one we've already seen for a refresher. The first demonstration is the can crush, in which we crush a can without touching it with our hands. The setup is simple. We heat a can with just a little bit of water inside until the water is boiling. We then overturn the can into ice cold water. And voila! The can crushes. It might look like magic, but we can actually explain it using science. Here we have our setup for the can crush demonstration. We have our can sitting on the hot plate heating up, and next to it we have the cold water bath all ready for it. And here it goes.
Oh!
Maybe you already have some ideas about what happened in that demo, but I'm not giving anything away quite yet. We'll discuss this later this week as we put together our newfound understandings about gases and their behaviors. Hint, it has something to do with gases. Now let's take another look at a demo from last week, the beaker and flask demo. In our beaker and flask activity, we started off with a beaker full of cold water, and we put some boiling water into our flask. Then we swirled our flask around, making sure that the air inside the flask heated up. You can see the swirling action. We found was that when we swirled it enough, the glass started heating up, and that was a good sign that it was ready to go. Not quite ready. Keep going. Once the air inside of our flask was hot enough, we poured out the hot water into another beaker, and we overturned our flasks very carefully into the ice water. Let's do some careful flask action there. And a little spillage, overfilled it. But what we can quickly see is the water rising up into the neck of the flask. One thing that we want to keep in mind in this activity and observing this activity again is that we don't really care about what's happening to the water, except that it tells us what's happening to the air inside of the flask. So if the water is rising up into the neck of the flask, what does that tell us about the gases inside that are trapped inside that flask? Now let's refresh our memories about doing the reverse of the previous experiment. So this time with the boiling water in the beaker and the icy cold water in the flask, swirling that thing around, making sure it's nice and icy cold, dumping out that cold water. Right now the air inside that flask is cold. We're overturning it into hot water. So this time, instead of seeing the water rise up into the neck of the flask, instead we are seeing bubbles come out of the flask. So remember that bubbles are a sign of the air escaping the flask. So then what does seeing bubbles tell you about what's happening to the gases inside that flask. Let's just get a few more bubbles out of this flask, and then we're going to move on to some explanation. So when we're thinking about why did this happen, the questions we want to ask ourselves are, first, what variables are involved? In this case, we have the temperature of the gas, which is what we were changing, and the volume of the gas, which was what we observed, right? So that's the very first thing that we want to ask ourselves, or what's involved. And then second, we want to ask ourselves, okay, if we change this one thing, what was the effect on the other thing? So we first changed the temperature of the gas by making the gas colder, right? That was our action. And then, or our independent variable, right? And then what is the effect that we're seeing from that? So what actually happened to the volume? It's our dependent, like measurable variable, right? So when we decrease the temperature, what happened to the volume of the gas? Did it increase? Did it decrease? Right? So that's the kind of things you want to be asking yourself.
All right, so let's move on to a new demo. This one involves marshmallows. This time, instead of looking at the relationship between temperature and volume of a gas, we're going to see what happens when we change the amount of pressure applied to air in a sealed container, so the gas inside a sealed container. We are going to use marshmallows as a proxy to help us visualize what's happening to the air particles, because air is kind of hard to see, y'all. So let's take a look.
Okay, so what we have here is a one syringe. So this, we have the syringe, has an opening. This one you probably used to feed small animals. It has a plunger, right? And so we can adjust the space inside here by changing how far we put. Now, when we push the plunger in, we are going to be applying force, right, on whatever's inside of the plunger. This also means that we're increasing the pressure, right? More force, more pressure. Pressure is force divided by area. So the larger the area, the force is applied, with less pressure. Smaller area, we have more pressure, which is why a needle will pop a balloon, but not your fingertip. Unless you press really, really hard, i.e. use a lot of force. So in this scenario, what we're going to be thinking about is we are going to be applying pressure by pushing and reducing pressure by pulling. Okay. The key of this is we really have to cover the end because we want an airtight environment. We don't want to be adding any air by pulling in out or losing any air by pushing. Okay. So to help us with this, we are going to take this apart. We're going to put one mini marshmallow. Obviously, very tasty. Chemistry, not cooking, therefore no eating. Can't eat through a video anyway, Lucy, come on. So we're gonna put that one mini marshmallow inside once it escaped and put our lid back on. So start off by pushing the plunger. So we're gonna be applying pressure. Now, get down here so you can see this really good. Keep a good eye on what happens to the marshmallow. Cover this end and see? I don't know if you can see this. Move it a little closer. See that? When more pressure I apply, ooh, the wrinklier it gets. There we go. See? Reducing the pressure, letting the plunger out. Still covered. Try this again. Do a good watch on that marshmallow. Oop. Come on, guy. There you go. All right, apply pressure. Applying more and more and more and more. That marshmallow's getting really goofy looking. All right, so now I'm gonna replace this marshmallow with a fresh one, because why not? Got a whole bag. Okay, so we have a new marshmallow in there. I didn't actually have to do that. It's just giving you a fresh one gives you a more accurate picture sometimes. All right, so now what we're gonna do is, instead of increasing the pressure, we're going to reduce the pressure. So I pushed this in so the space inside here is smaller. I'm going to cover the tip with my finger, creating an airtight environment. So now what I'm going to do is I'm going to reduce the amount of pressure on the gas inside this container. All right, ready? So this one's kind of a hard one, so you have to pull it. All right, so the more I pull, the more I am reducing the pressure inside this plunger. I lifted my finger, and what happened? It went straight back to small. Right before it was super big. And I reduced the pressure. Let's see if I can do this again. Make the space really small, cover it up. Sometimes when you do this part, the marshmallow breaks. Pull it. Ooh, this one's hard. Yeah, so how big it gets? Oh, this one's kind of died. All right, you get the picture? Pretty cool.